What a great day. What an exciting time. The museum is very pleased, of course, to partner, as you just heard, with NASA to present today's panel discussion commemorating the 40th anniversary of the Apollo 11 mission and exploring the future of space exploration. Very pleased to be joined by science centers all across the country. We are going to have questions from them, some of them as young as 8 years old. They're going to be very tough questions, you can count on it. They'll be submitted all over. Also, we're going to be asking those in our studio audience to prepare questions and be part of the program as well. Now, this event, of course, that we're going to show you right now, this very brief film, this is now a very brief, I think just 2 minutes long, and it, of course, shows the centerpiece of the event, which is the reason we are here celebrating today. Take a look.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth.
T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5.
How far out are we now, Charlie?
Stand by, I'll give you an exact figure. You're now 177,000 miles out, over.
Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
And we're getting a picture on the TV. There's a great deal of contrast in it, and currently it's upside down on our monitor, but we can make out a fair amount of detail. Okay, Neil, we can see you coming down the ladder now. That's one small step for man, one giant leap for mankind.
How wonderful that is. Okay, let's take a look at our panelists. First of all, let me introduce to you Buzz Aldrin, Lunar Module Pilot, Apollo 11. Charles M. Duke, Jr., Lunar Module Pilot, Apollo 16. Laurie Leshin, Deputy Director for Science and Technology at the famous Goddard Space Flight Center. And closest to me here, John Grunsfeld, Mission Specialist aboard STS-125 Atlantis. He was the lead spacewalker, as you will remember, very recently during the Hubble Space Telescope repair mission. Had our hearts beating for a long time there. I just wanted to let you know where these youngsters are going to be talking to us from. There will be the science centers all over the country. For instance, the Museum of Science in Boston, the American Museum of Natural History, that's in New York, the California Academy of Sciences, the Museum of Science and Industry in Chicago, and the Denver Museum of Nature and Science, and one more, the St. Louis Science Center. Now, let's begin talking to our panelists. We're going to begin with you, Buzz, and I'll tell you why. Because if I understand correctly, You are going to you might have to leave us before the end of this program. There's something about 10 blocks away. What is it, late lunch or something? What's going on?
1600 Pennsylvania Avenue.
And
Call the
you
White
would
House.
desert us. That's great. Be looking forward. Now, you did a commentary for CNN just a couple of months ago that was darn interesting. You thought that we would need to inspire youngsters more than we're doing now. And you thought the way to do that was with the mission to Mars, manned mission to Mars. But more than that, you used the word, and not just to make a mission, but to homestead Mars. What do you mean by that?
Well, it's not going to happen within a decade. And it's not going to require breaking the bank right now. We can maybe save some money by realigning what we're doing and then a gradual course. How about the moon? Well, we got a lot of experience on the moon 40 years ago, and we have an awful lot of experience on the moon the last 4 years because we've been planning on going there ourselves. So we can take that experience and communicate it, help work with the international nations. Will they come together for the moon? I don't know, but they have an umbrella organization that's over and above the International Space Station. So we need to start there and bring in China, bring in India, South Korea, the other spacefaring nations into the space station. And based on that, we have an International Lunar Economic Development Authority, corporation, whatever it is. And the U.S. says, we're going to help you people all you want because your nations and your international groups want to land on the moon. We do too, but we'll ride with you in your rockets and your spacecraft because we're going to take our resources that we put into the International Space Station to the tune of $100 billion. Okay? We're going to take our resources and establish a pathway that may take a little more than 2 decades. But it is a pathway that will achieve more things than dedicating a return to the moon right away.
That's a pretty aggressive plan, isn't it?
Well, yes it is, but there's no reason why at the International Space Station we can't put a test module of the long duration life support equipment that we've sort of been hopefully developing all these times, but in the same time we develop an exploration module that can accompany Orion on 1-2 year missions. You're not going to put people inside an Orion Apollo-like capsule for 6 months at a time. No, you're going to put them there to go to the moon and come back, but how about going to much longer distance? You've got to have more room, you've got to have the equipment that can support these people with the redundancy that doesn't require you cramp it all together for a launch. You make it larger, and as a matter of fact, you can model this sort of thing after a Mars habitat and a Mars lander so that we're looking at those vehicles and we're using those soon to begin to plan outward movements.
You know, Thursday night in Dayton, Friday night in Dayton, you told us something, all of us assembled in the audience, something that we didn't know before, at least I didn't. And according to their reaction, they didn't either. This is on the moon. You and Neil, the first ones to step out onto the moon. You told us there were a couple of other firsts there as well. Would you like to tell the people what you told us?
Well, I failed my first assignment on the surface of the moon. It was to get down to the bottom and jump back up again. I was overconfident. I'd done a fairly great job spacewalking on Gemini 12, and I was a little overconfident. I didn't think the lunar gravity at 1.6 was going to be that big. So I jumped back up and missed. Okay, next time I made it. Why did we do that? Well, because we knew we couldn't take the rock boxes and climb up the ladder with them. We had to send the rock boxes up on a clothesline. And the same clothesline was used to send the camera down so that obviously Neil could take my picture when I came down the thigh. Excellent photographer. That's not what you're talking about, is it? No. We had great confidence in the inside the spacesuit plumbing. We had great confidence in the backpack, the mini spacecraft on our back that gave us the electricity, the water-cooled underwear. And of course, the life-sustaining oxygen with an emergency oxygen on
That's
top.
not what I'm talking about there.
No, but we had great confidence in the interior plumbing. As a matter of fact, we just emptied it all out so that we could throw it out on the surface later on. So there was plenty of capacity in the UCD, urine collection device.
You tried it out.
And I just had that moment. You know, I knew when I got to the bottom of the ladder that it was clearly going to be very easy to walk around the moon. What am I supposed to do for the next 30 seconds while I'm checking stability? Maybe we're a little nervous here and there, but what I do is I talk about things that are human. And I talk about how people are compelled and really worried about what they're trying to do. They're not worried, but they're alert to what they're trying to do on the surface.
You remember what you said?
I said magnificent desolation. Not right away, but I gave it a little bit of thought. And the magnificence of humanity, mankind, coming down from the trees or wherever we came from, and then doing all the things necessary to get steam,
He's not going to tell you what he said.
rockets,
Not gonna tell you.
spacecraft, and putting
I'll tell
people
you
on
what
the
he said.
surface of the moon.
I'll tell you what he said.
And it's lonely as hell up there.
Maybe I won't tell you what he
I
said.
peed in my pants.
What he said
but
was,
poor Alan Shepard, when he sat on that Redstone rocket, he didn't have a UCD. So he was floating on water for a while before his 15 minutes of flight.
well, that's great, Buzz. What Buzz actually said to us on Friday night was, well, maybe Neil was the first one to walk on the moon, but. I want to talk
He
to you.
hadn't disputed that fact. He had 20 minutes to set another record.
Charles, Apollo 16, there were some problems.
Yeah.
Particularly, bring us up to date. Remind us what went on as you were just getting ready.
Well, Apollo 16, like all the other Apollo flights, had problems. You know, you look back now 40 years and we had 6 landings and everybody, well, that's a piece of cake, but it wasn't a piece of cake. I mean, landing on the moon is a really difficult task. And not only are you coming into an area that nobody's ever landed before, but you've never seen it in detail before. The photographs we had of our landing site were 15-meter resolution, so, and there are a lot of big craters that can put you in trouble that are 30 feet across or 10 feet across. And so we were coming in and we were seeing all of these craters, and we had to pick a landing spot. But before that, we were on the back side of the moon with Mattingly, and he had to change his orbit in the command module, and that required a major engine ignition with what we call the service propulsion system. And as he tested this out before the ignition, it was rattling the spacecraft to pieces, he said, and he said, I can't burn. Well, if your heart can sink in zero gravity to the bottom of your boots, ours sank to the bottom of our boots because that's an abort. And so you'd come 250,000 miles, you'd train 2 years, and 8 miles down there was your landing site, and they're about ready to tell you to come home. So you can imagine how disappointed we were. But the teamwork that we exhibited, not only to get them to the land, to Apollo 13 back safely, and all the other problems came into focus and up to speed, and 6 hours later they said you're go for landing. So down we went, and from then on it was fantastic. So our heart went from here to here when we heard our Capcom Jim Irwin say, we're going to give you, next time around, you got to go for landing. So,
And you were there for a long time?
We were there for 71 hours and 14 minutes. NASA put us in for the record stay, so we had the record for longest stay until the next flight, Apollo 17. They actually stayed about 75 hours.
Mm-hmm.
But
Did they just for spite, didn't they?
They did it just for spite, yeah. We pleaded for mission control. 2 hours more, guys, just 2 hours more, that's all we want. And they said, get back in, it's time to come home. So.
What do you see as the future of manned space flight?
Well, I would like to see us back into deep space. We got a big investment in International Space Station. We need to use that. We've got, and there's a lot of ways we can get a return on that investment. Going back into deep space, I think, kindles the human spirit of exploration. Buzz and I have a little disagreement about should we go to the moon with our resources. I agree it should be international, but a return to the moon, I think, would be also an opportunity to develop some of these systems that we're going to have for a Mars stay. He wants to do it in ISS, which is not a bad idea. I'm think back to the moon, but whichever way we do it, it will just be a stepping stone out into the distance. And I hope that I'm around to see those first footprints on Mars. And I think that the technologies that we develop for that as a capital expenditure for our country will reap great dividends for us, and we'll have a great return on our investment.
Thank you, Charles. And I agree with you. I hope I'm around to see it too. How old are you? No, I'm not going to ask you. Laurie, before we get to you, we have standing by right now with a question for Buzz, who, as we say, might be getting out of here pretty soon. This is from the Museum of Science in Boston, Buzz. This question is coming to you from 8-year-old Marcus from Cohasset, Massachusetts. Now take it easy on him, Marcus, okay?
Hi, Buzz. My name is Marcus. I am 8 years old. I would like to go to Mars one day as an engineer or scientist. What should I study in school? What hobbies are good for an astronaut?
When I was at MIT, I lived in North Scituate, not too far from Cohasset. So I know right where you're coming from. You need patience. You need to communicate with other people. You need to have, I think, something that separates you from others. You're going to have an evaluation of considerable weeding out of other people that are trying to do the same thing you'd like to do. Let me ask you, when you say you want to go to Mars?
Marcus?
Yeah?
Marcus?
Yeah. How long do you think you're going to stay when you get there?
I don't know, a few days.
How long?
No, he said stay.
Yeah, well, that's a normal answer. There was somebody at some event, and they said, my son is 8, and he's going to go to Mars. So I said, how long do you think you're going to stay? He said, a couple of days. And I said, well, it may take you a better part of a year just to get there. Why would you want to stay only a couple of days? Why would we want to invest all that money in sending you there and then bring you back? You're not going to give us all that much science or that return. As a matter of fact, nobody's going to build a 50-person spacecraft to send the first people to the surface of Mars. Now, there is a critical number of people that need to be there to do the things to make a sustaining group. And it's bigger than 6. It's maybe 50 or 60. And you know how long it takes to accumulate 60 people? Every 26 months, you can send another mission to Mars. It takes 22, 23 years to accumulate enough people. We need to rethink a good bit about, are we really ready to venture out that far? And what does it really take? I think we're ready to think about that, but we have a pathway that can branch off to asteroids, that can, if somebody discovers something really important at the moon, and I'm not sure what it is, that justifies the investment in habitation for people of a nation that by that time will have stayed on the moon 50 years ago. You realize that from Kitty Hawk to Tranquility Base was 66 years. Now let's go 66 years into the future. That's 2035.
Marcus, you'll be
We don't want to be kicking up dust back on the moon. Now, Marcus, I think we'll be doing some real man-to-man talking about how long you might want to stay, whether you want to spend the rest of your life on Mars or until we come up with warp drive so we can bring you back in a couple of days.
Thanks a lot, Marcus, and we appreciate the question. Just before we get to our next question, which is going to be for you, Charles, but before we get there, I want to talk to Laura for a moment. This proposed new manned mission that most people are talking about, the one going back to the moon. Now, is this sort of back to the future? Tell us what's going on. We're not using the shuttle technology. Are we using the Apollo technology this time?
It looks more similar to Apollo than like the space shuttle. It's a capsule that people ride in, but this time we'll be sending at least 4 people back to the moon, and they'll be riding in this point separately from their descent capsule, and they'll rendezvous in Earth orbit and go down to the moon. And right now, with an orbiter, an unmanned orbiter that's in orbit around the moon called the Lunar Reconnaissance Orbiter, we're taking pictures of prospective landing sites. As Charlie said, they only had very poor resolution images when we went there with Apollo. We are going to make an incredible map of the moon with LRO. You can go online and see some of those first pictures right now, and know exactly the most interesting places to go, the safest places to go, and the places where there might be things we can use to live off the land once we get there.
I just learned this weekend that we have a much better maps of Mars than we do of the moon.
That's absolutely true. Right now, the instruments that are in orbit around the moon on LRO, it just got there a couple of weeks ago, are going to change that. They're going to make our maps of the moon just as good, if not better, than our maps of Mars.
Charles, this question is coming to you from Anna. This is from the American Museum of Natural History in New York. This is for Charles. Anna?
Having spent over 20 hours outside the lunar module, what do you think is the possibility of human beings being able to live on the moon? And with what kind of support?
I missed that. I'm sorry.
What do you think is the possibility of living on the moon? What kind of support would be needed to do that for extended periods of time?
Hopefully we'll establish a base that, if that's what we decide to do, is return to the moon, we'd want to establish a base similar to what we have in Antarctica. So it will require supply modules, and I think we can develop technologies that we can use to extract oxygen, hydrogen from the rocks, and utilize the resources there eventually to help us to inhabit this area of the moon for a considerable time. And I think that's what science wants us to do, is to go back and build a science. There's a lot to learn about the lunar surface. We've just scratched the surface, and so maybe it's not such a bad idea to look for that.
Thanks so much, Anna. And Laura, I really want to talk to you a little more about that later, because that's one of your specialties, of course, searching for water and the water in and on various heavenly bodies in the solar system.
That's right.
But before I get to that, I certainly want to talk to John Grunsfeld, who gave us heart palpitations not so long ago. I understand, of course, that you practice for all eventualities in trying to repair the Hubble telescope. But for heaven's sake, no matter what you rehearse for, what surprises did you find that scared you as much as it scared us?
Well, as you said, our team on STS-125 Atlantis, commanded by Scott Altman, trained for 2.5 years. A lot of that training was just, the nuts and bolts of putting things in and out of Hubble, but much of the training was what to do when things don't go well. And so we trained hundreds of different scenarios where this wouldn't work quite right or that wouldn't go in. And we had 116 tools that we developed just for this mission, over 400 different tools, power drives and wrenches and screwdrivers and things like this. We got out the door with the first spacewalk and went to the first major task, which was to replace an old camera with a brand new amazing camera that's up on Hubble right now, the Wide Field Camera 3. And to remove the old camera, we just had one big bolt to turn, and that bolt didn't turn. With all the force we could put on it, with the initial set of tools, and there was a pretty good risk that that bolt would break, and that would be the end of this camera. Fortunately, just a little bit of extra elbow grease and another tool, and we got it. But we talk about hard sinking. This was the primary, highest priority science on the mission, and the very first thing we did, and that first bolt didn't turn. My heart was pretty low in my boots, even though we're in weightlessness. I think there's a point at which I say, before we do this potentially game-ending event. Let's think about every alternative, and we did, and we found a way to get around it.
In fact, we have a question for you. This one is coming from the Museum of Science and Industry in Chicago. I think we have a moderator there, don't we?
Yes, we do.
Go right ahead.
Okay.
This is for John.
Hello, my name is Sasha Blakely from Vancouver, Canada. I'm 13. My question is, what do you think is the next main technological breakthrough that is essential for the success of the next phase of long-term space travel to the moon or Mars?
So the question was, what's the next technological breakthrough for exploring Moon and Mars? I think there are so many challenges that we have to overcome to be able to develop a colony to live on the Moon. I think using resources that you find every time explorers have gone out in terrestrial exploring the Earth exploration, they've had to utilize resources that they find when they get there. So I think utilizing those resources on the Moon to generate oxygen that we breathe, going to Mars and being able to develop rocket fuel that will allow us to come back so we don't have to take so much rocket fuel with us to get there. Those are some big examples. I think being able to build life support that in a contained environment, such as a module that you would live in, to be able to recycle everything and keep it clean so that you're breathing clean air. Those technologies we haven't refined yet. We can do it for short periods of time on the space shuttle. We're learning how to do it for longer periods of time on the International Space Station. As we entered this conversation, we talked about a urine collection device. Well, we actually are taking urine on the International Space Station, purifying it into really pure water. I have an example right here. and the astronauts and cosmonauts on board the International Space Station are drinking that water. Those are some small examples. I think in the big examples, we're really not going to go explore the solar system, where we can go to Mars in a period of days until we have some new form of propulsion. Chemical propulsion can only get us so far. If we really want to explore our future, and our future is out there in the cosmos, we're really going to need a fusion-powered drive or something like that. That's technology that's totally accessible to us, but involves an investment and some time and some really creative young engineers and scientists.
Thank you very much for that question. Appreciate it. I did want to get back to the question of water in the solar system. Is there empirical evidence that there is water elsewhere in the solar system?
Yes,
Laura?
and I'm drinking some of it right here. In fact, I spent most of my science career heating up samples of other planets and extracting water from them, like Mars. So we've actually analyzed water molecules from Mars right here on Earth. So we know that there's water on Mars. The Moon is a big mystery when it comes to water. There are craters near the poles of the Moon where it's dark all of the time. And so it's very, very cold. And there's some evidence from spacecraft that have orbited the Moon that there could be frozen water trapped in those dark places. And again, one of the objectives of the missions that are going to the Moon right now is to see whether that's really true. And if there really is water in those dark craters, what a fantastic resource for the people who could go back to live and work on the Moon. So that's a huge question still. And of course, water is so critical if you want to think about life on other worlds. Liquid water is really what you need, not frozen water. So places like Mars, where it could be liquid, places like the moons of Jupiter, where below an icy crust could be a liquid water ocean, are places that we want to explore initially with robots and maybe eventually with humans to try and answer that most fundamental question, are we alone?
Yeah, I wonder if that question will come from Denver, because the question is for you, Laura. This is from the Denver Museum of Nature and Science, and we're standing by for the question. Go right ahead, please.
Hi, Dr. Lessin. We have a question from Shelley at the Denver Museum.
Dr. Lessin, I've heard the idea that the Moon was formed by something hitting the Earth early in the solar system's formation. And I'm just wondering if material brought back from the Apollo missions has helped to prove that hypothesis.
Yes, very good question. Excellent. So you've all heard of the Big Bang theory of the origin of the universe. We call this one the Big Whack. This is the leading theory, the leading hypothesis for the origin of the Moon is something called the giant impact hypothesis, where an object that's about the size of Mars is about half the size of the Earth, hit the Earth very early in its history, and the material that was spewed off in that giant impact actually then agglomerated, accreted together to form our Moon. Sounds crazy, I know, but in fact it's the leading theory for the formation of the Moon. Now, when we went to the moon with Apollo, there were actually 3 leading theories about the origin of the moon, and the big goal of Apollo was to sort out which one of these 3 theories was right. And the scientists would get together and they'd argue and they'd fight. Well, they brought back over 800 pounds of rocks from Apollo. When we analyzed them, we found out that none of those 3 theories were actually right. And actually, from the information that we measured with the Apollo samples and other missions to the moon, the giant impact theory has emerged as the most credible hypothesis for the origin of the moon. It's not perfect yet, though. We still have some things that we need to tweak and understand. So going back to the moon, getting more and different rocks, measuring the interior structure of the moon are all things we need to do to really nail down whether the moon formed in a giant impact.
Thank you very much for that question. Really appreciate it. I have a homelier question about the material on the moon. I wanted to talk to you about it.
I just wanted to ask you a question. What is there about the science on the moon that we really cannot do with robots? Why, and especially some international people who may be there who can help fix the robots. Why is it that the United States has to make that major investment? I talked to Charlie before, and we can certainly look at this long duration systems that we are working on. We can look at those at the space station beginning in 2015, 2016, and prolong the life of the space station, which many people would like, far simpler than we can waiting until 2020, 2025.
Oddly enough, that was my question.
To try the things out on the moon. Much easier. You know, as a matter of fact, we could put a human at Earth Moon L1 much safer than on the surface of the moon, and he could control the robots on the surface, because that's what we want to do at the moon of Mars, Phobos. Much more efficient than people that send to Mars 1 day's worth of instructions that are conservative, so that if the robot there runs into any trouble, stop, don't do anything. We'll get back to you in a day and tell you what to do. Spirit and Opportunity have very nicely lived for 5 years instead of 90 days. But if we had a human being at Phobos orbiting every 7 hours, what could that person do? He could be controlling that robot in real time. That's
would
much
be
better.
excellent.
The moon is automation. Mars requires being there. And the supply chain you set up, it doesn't let you go there and come back right away.
Laura, is this a debate? Is that what's going on here?
No, actually, what I was going to say is, from a science perspective, what I can tell you that we need to really unravel these mysteries is we need a network of places around the moon to do like a seismic station, like you'd measure earthquakes on Earth, to study the interior of the moon. You could do that robotically. You could also deploy it with people. It's a choice. But we also need rocks back from a wider variety of terrains on the moon. You all explored, amazing. You know, the Highlands is incredible, and of course the Mare. But we've only explored a very small part of the moon, and to really answer the questions, we actually need to go some other places. Again, you could do that robotically. I think people, especially in the selection of really interesting and important samples, become more important. But again, it is a choice we can make all along the way.
All we got to do is learn Chinese and ask them to find whatever we're looking for.
And of course, I agree with you. On Mars, I think...
you don't have to speak Chinese at Phobos or Mars. You speak American.
Well, I think our first Mars walker could be out here. Would she raise her hand, whoever she's going to be?
Buzz, it's my understanding that the moment has come for you to go to lunch. Is that right?
I think so.
That's what I hear. I think they're waiting for you.
Just in preparation, I already had a nice sandwich.
Just in case.
I don't trust the White House lunch.
Remember while you're eating that lunch, we all paid for it. I want you to think of that. Okay. Buzz Aldrin, ladies and gentlemen.
Thank you very much. Thank you, guys.
This is great. You know, that's great. I had one other question to ask Buzz, because I was reading an old Life magazine. I mean, old Life magazine. I collect them. And there was a story about the lunar landing. I can ask you, Charles. Buzz was quoted as saying then, 40 years ago, that the material he brought back up from the moon had a distinctive odor. Did you notice that as well? Is that true?
Well, it sure did. It was a real surprise to me that when we got back inside, we had not only the samples, but also the dust that we brought back in with us on our moon boots and suits and stuff. And I took off my helmet and my gloves and picked up some, and the stuff is as dry as toast, of course, because there's no water there that we know, at least where we landed. But it picked up the oils of your skin, and it felt like graphite, and you could smell it, and it had a gunpowder smell to it. Maybe Lori analyzed them. Maybe she can tell you why, but I can't tell you why, but it did.
Well, she's shaking her head, so I'm not going to Laura for this one. But we do have a question coming in, and this one, let me see. This is for you, Charles, and it is from the St. Louis Science Center. A question for you, and it is from, I think we have a moderator. Do we hear now from St. Louis? St. Louis Science Center. A question for you, and it is from, I think we have a moderator. Do we hear now from St. Louis?
She's been to space camp twice. She's 13 years old, an 8th grader at Oakville Middle School. Abby Trimble, take it away. She's been to space camp.
My question is for Stu. What was the hardest part physically and emotionally of space travel?
We're having obviously some feedback problems with it. Did you hear the question? Okay, good.
The question was, what was the hardest part emotionally and technically in space travel? For me, I think the hardest part was the landing on the moon. As I tried to share with you earlier, we were coming in an area that was unknown, basically, at least from a landing standpoint. We could identify Stone Mountain and Smoky Mountain and the major craters as we came in from an altitude of about a mile above the surface. But as we got closer, we had to maneuver into an area that would allow us to be almost as level as possible so that we could work. The LRO has just sent back some photos of our landing spot with a low sun angle, and you see this big crater behind our spacecraft. And we didn't even see it. Fortunately, we got over it by about 3 meters and landed, and then we're looking out to the west. It was just a fantastic scene. But then we came around, I got out and went around to retrieve the Apollo Lunar Surface Experiments package, and I looked at it, I said, John, look at this. And it was a big crater that if we'd have landed there, it would have not turned us over, but have been very, very difficult to retrieve the experiments and things out. So that was the hardest part. And emotionally, it wasn't hard I wasn't even trying to control my emotions. I was so excited, like a little kid at Christmas, you know, and that's the way John and I trained, to have fun, but to do the job and to be animated about it all. And it turned out to be the best for us because we worked together that way better. And so emotionally, it was just a high for 71 hours.
And any residue after you got back? We have heard that some, including Buzz, has spoken openly about it, that there were some emotional afterdrafts.
Not for me. There was, as a direct result, I don't think anybody as a direct result of moon flight had a physical or a psychological problem. But after you come down from that high, and yes, now what am I going to do? That's where the things can cause you to go off. And Buzz has acknowledged that in his book. And all of us decided that we needed to do something else. John Young, who was my commander, stayed on at NASA, finally retired in 1995 at 44 years as an astronaut. 2005, I'm sorry. And so I left after 10 years to do other things. So it was the after part of, John, you're probably going to have the same problem, you know, after that thrilling adventure of repairing that Hubble. Now what are you going to do? Hopefully they got a good mission for you coming up, because that drive that takes you there is still there, you see. And so how do you channel that drive? And And that's the human spirit, you know, we've got to go explore.
Question coming up now. This time it's from the California Academy of Sciences. And I believe we have a moderator standing by for the question.
Hello, yes. I was just wondering, what experience surprised you the most about Apollo 16 mission? Scary, humorous, or inspiring?
The question is, if I understand correctly, would you describe the adventure that you just gave us a little outline on as more inspiring, more humorous, or more scary?
My first choice would be inspiring, not only to us individually, but I think to especially the kids of the world. They dream. When I was a kid, 12 years old, there wasn't a space program. And I didn't go out in the backyard and look up into the heavens and say to Mama, I'm going to walk on the moon one day. Mama would have dropped a net on me and sent me to the psychiatric hospital. But I did have heroes, and they were in the great generation of World War II. And so now we have that opportunity to inspire the kids of the world to dream and to aim high. The second would be let's see, there was
scary, inspiring.
Inspiring was, and then
humorous.
Humorous. I think the second for us would be the humorous part, because John and I had a good time, and he's a great humorist. My third would be scary, and there was only one moment when I had a scary incident, and it was doing something I shouldn't have been doing. And so kids, hear this, you always get in trouble when you do something you're not supposed to be doing or you hadn't practiced for it. And so we were going to set the high jump record on the moon, and and my backpack weighed 155 pounds. Is what I weighed back then. And so when I jumped, I straightened up. Well, my center of gravity went backwards, and over I went like this. And I had really a moment of fear there, because I was falling on my back, and this backpack's not designed for that. Fortunately, I was able to roll around and break my fall. But let me tell you, that ended the Moon Olympics.
For now.
For now,
Maybe
yeah,
later.
That's right. And Mission Control was very upset, by the way. They thought they'd lost somebody.
And Gene Cernan didn't try to break your record, right? He did not.
I thought you were going to talk about driving the rover.
Well, the rover was I was really the navigator. John was the driver.
That's what
And riding with John, I called him, for the older, you hear one of the old race drivers, Barney Oldfield. And I said, here comes Barney Oldfield again. Man, he was really flat out on the moon, and we set the moon speed record at the time, 11 miles an hour, and we were bouncing like this. I'm glad I had my seatbelt on, boy, because the lunar rover only weighed 80 pounds on the moon, and so with the springiness, and it would hit the bumps and the rocks and the little gullies and the small craters, and we just bounced all over the place.
This is great stuff. Yeah. This is great. Listen, I wanted to give you all a chance here in the studio audience. This is your big chance. If you have questions you would like to ask of these wonderful people, we're going to have to ask you to come to that microphone right over there. And while you're making your way, I can tell you that there was a question from museum.org via Google Moderator, and it is, let's see, it's a toss-up. It's for all of you. So let's start with you, John. How far do you think the United States should go with space exploration? Do you set limits, I gather, is what the question is.
Well, I think there's always limits that you have to set in terms of funding. What can you afford? But I would say that, and of course I've dedicated my life to it, that it's the most important thing we do. Exploration is the most important thing we do. It brings all of the new innovations and technology that make our lives worthwhile. That's what I believe.
Okay, let's take it on down, Laura.
I think great things happen when we set impossible, audacious goals. And I think that space exploration is one of the things that allows us to do that, to dream beyond what's possible. And so that we shouldn't think about it in terms of limits. We should think about it in terms of striving for that next incredible thing that we can't even imagine that we can do, but we go after.
In one famous phrase, we don't do it because it's easy, but we do it because it's hard.
That's right.
That was John Kennedy's statement, and that's true. I think the human spirit is that spirit of exploration. That's why I volunteered, because I wanted to be an explorer of the first order. And I think in the future, that spirit is still here with us and will lead us on to more knowledge of the moon and then on to Mars. Eventually, we'll get there. I don't know in my lifetime, but I would encourage everybody that are studying now, the kids, to do their best and to look out into the future. The mountains we climb will allow you to see farther on with a new technology that we would not imagine.
I think I hear the voice of the next astronaut. Okay. We have some questioners standing by right now. Ready?
Mr. Duke, I was wondering, was it more nerve-wracking for you to watch the astronauts that landed before you, wondering whether or not they were going to be able to successfully land and then come back? Or was it more nerve-wracking actually being the one there that was landing and then coming back?
Probably the latter. It's more sitting in mission control, either as Capcom or backup, and just monitoring. It's more nerve-wracking to listen to it and to wring your hands because you're not in that dynamic situation. Once you're there and you get to do it, you're so focused on the operational side of it, you don't really have time to worry about, oh my Lord, what am I going to do if this thing doesn't work? Or, I mean, you wouldn't be there if that were your situation. But listening and watching in mission control is you get anxious. You want them to succeed so much that you get anxious about it.
I will say, can I just add, I was in mission control when they were trying to turn that bolt on the Hubble mission.
Oh.
I will tell you, people think that scientists are, we wear lab coats, we're not emotional. People were crying because they had devoted 10 years of their life to building this camera that might not get in if this bolt broke. And yeah, it's nerve-wracking. We were all wanting to turn that wrench for you.
Yes, another question.
My name is A.R. Hogan. I'm a science journalist, and I'm also a graduate student at the University of Maryland doing a doctoral dissertation on the history of television and radio coverage of the space program. And I wanted to ask your reaction to what impact the amazing coverage on television of the Apollo lunar explorations, some of it at CBS News, of course, produced by Robert J. Wessler, directed by Joe Bano, and anchored so wonderfully and ably by Walter Cronkite. I can't bring myself to say the late Walter Cronkite. It's so tragic we lost him last Friday. But could you talk about the impact of this television coverage on the public, and also those of us who, like Walter Cronkite and probably most people in this room who are space enthusiasts, how can we manage to get those who are inexplicably not, how can we get them to get it, why this is compellingly important for our human species to do, please?
John, why don't you start that?
I'd just like to lead off because Charlie talked about inspiring, and there's absolutely no question that Charlie Duke and John Young were my heroes as a kid. I did tell my mom I wanted to go walk on the moon, and while I haven't walked on the moon, going up to Hubble 3 times as an astronomer has been my holy grail in space, and there's no question that inspired me. And I grew up in those 1960s when the two major events in my life were the space program and televisions appearing in American homes. And so I think it was that sort of serendipitous conjunction of television and my seeing these very important, very exciting explorers go off and do something truly great. That set me off on a lifetime of discovery.
So the coverage was intrinsic to your interest.
Yep.
Now, was that also true? What impact do you think that all of that coverage, including obviously
I think
Walter
the coverage is very, very important. And the earlier flights, every minute, every second was covered on TV. By the time we flew, hardly any of it was on TV. So that my family, my parents and my wife and kids went to mission control and sat in a visitor's viewing room so that they could watch us on the moon. And to me, that's okay. It's an evolution of knowledge and experience that we get that sort of fades away in the public knowledge, but doesn't take away from the importance of what we were doing. You know, Lindbergh flew the Atlantic. Everybody remembers that. Nobody can say number 2 who flew. The first 747. Now we got 747s flying back all over the world. Thousands of people. Doesn't make the news unless one crashes. But anyway, it's that what we do doesn't distract from what we accomplish.
But
I mean, I didn't say that right.
No, I know exactly what you mean, but I wanted to ask you this question then. Didn't the celebrity of those early astronauts, did that not help to gird the Congress and all of the rest of us for the very difficult and expensive task that lay ahead?
And it did, and that's why I spend a lot of my time now going around and speaking to groups to try to encourage them to try to rekindle that adventure, because the future is the future, and we need to get excited about it and invest some of our resources to make that capital investment into the future for a return.
Another question.
Yes, I'm Rita Carl, Director of Education for Challenger Center for Space Science Education, and we fly students to the moon all the time. And we have a student from our Challenger Learning Center in Richmond, Virginia.
Hi, I'm Navia Higgins, and my question is, what are some things that we have learned from space exploration that we can use to help our own planet?
Laura.
Oh, great question. Most people don't know this, but right now NASA has about 15 spacecraft orbiting the Earth, watching the pulse of our planet as it's changing and studying the basic physics that drive our climate and our weather to help us predict better how it's going to be changing in the future. Also, things we send to other planets, Venus and Mars, can help us better understand how planets like ours can change and evolve. So from a science perspective, we've learned a whole bunch about the history of our planet and how it's going to change in the future. But there's technology things that we get from NASA as well that help us. And I don't know if either one of you want to talk some about some of the spin-offs, like from Hubble imaging, for example.
Yeah, the Hubble Space Telescope helped pioneer the use of CCDs in cameras. And I don't know how many people out here have a digital camera. Yeah. Well, there's a little bit of Hubble Space Telescope technology in every single one of those cameras that's revolutionized the media and the news, because they're ubiquitous, they're everywhere. So people can take pictures of news as it happens and send it in. The technology that used to make those detectors, the semiconductor technology, some of the techniques that we've learned on how to build instruments from Hubble and the imaging have gone into the manufacturing of those semiconductors. And of course, you know, we're all concerned about healthcare and our own health. And some of the techniques that astronomers have used to see planets and star-forming regions, new planetary systems being formed, baby planets in stellar nurseries. The technology to identify those spots have also been used in medical imaging to help detect cancer in the human body. And so it's really a wide range of things, from, you know, the hard tech to the soft tech, us, that just Hubble alone, amongst all the many missions that NASA does, that have helped us.
Thank you for them. Yes, sir.
Okay, would it be easier or harder to find astronauts after the incident in Apollo 13?
For them to come forward, you mean? Was it easy? Was it?
Would they want to be astronauts?
Yeah, were there
would they want to be
just as many volunteers after Apollo 13 as before Apollo 13?
There's, as far as who wanted to go, you bet. We were beating the door down. You know, I'm ready to go. That's just the nature of an explorer.
He's Apollo 16, you know, just
he did go after.
And I did go after. We fixed that problem, and we didn't think it was going to happen again. It hasn't. The Challenger explosion, there was the crew that followed on after that, after Columbia, and that's the nature of space flight, the risks that we take, and there's not an astronaut there that doesn't understand that risk and is willing to take that risk for that next adventure.
Oh, these are great questions. Yes.
Yeah.
How far are we from achieving Earth gravity in space? Is Earth gravity in a space vehicle a prerequisite for traveling to Mars?
What are we talking about? Anybody up for that?
So the question really is, when we're in space, we're weightless because we're in constant free fall as we orbit the Earth. or when you're on your way to the moon. When you get on the moon, then of course you have 1/6 the same pull that we feel here on Earth. The great advantage of that is it's just a joy to float in space. It's truly magical, and it just changes the whole experience of being human. That's the good news. The bad news is that one of the reasons that we stay healthy is because we get up in the morning and we go out and we exercise and we walk around, and that makes our muscles and our bones and our heart, our cardiovascular system strong. In weightlessness, our bones and our muscles and our heart don't get enough exercise, and so our bones get weak and our muscles get weak. And so one approach to these long flights to Mars, 6-month cruises to Mars, would be to build some kind of a circular spacecraft that rotates, for instance, so that the acceleration that you feel is the same or some fraction of what you feel on Earth. And that's one approach, and that's an engineering problem, and that's something we could solve. Another approach would be to find ways and machinery, essentially gym equipment, that allows you to get enough exercise working against elastic cords or springs or other mechanisms. To get enough exercise, which you need to do anyway just to keep sane over 6 months. Most astronauts like to be gym rats. In fact, this is the first job I've gotten paid to go to the gym every day, and I kind of like that. But that's another approach, and that's the one we're using on the International Space Station. So one of the big goals of the International Space Station is to learn how to keep our bodies healthy over those long cruises. But artificial gravity, so to speak, is one other approach.
Just heard, if I understand correctly, what the person who's speaking into my ear told me a moment ago. This program will be repeated on NASA TV immediately after this broadcast is over, and also I think at all of the science centers which are hooked up with us as well. I think that's what they said. Got another question?
Hi, my name is Matthew, and one day I hope to be an astronaut. My question is for you, John. What was your reaction when you were the last person to grab onto Hubble for the final time?
Good question.
So the last moment I grabbed onto Hubble, of course, Scott Altman probably wanted to come out and pry my hands off. No, seriously, we made Hubble brand new, essentially. This was a complete Hubble makeover. We put in this new wide field camera with new detectors that is just going to blow everybody away when we see those pictures. We put in a cosmic origin spectrograph that's going to really look into the deep physics. Spectrograph breaks up the light coming from distant galaxies into its colors. It allows us to do the physics and astrophysics, understand the structure of the universe, maybe shed light on dark matter. We brought 2 cameras back to life, and we put life extending capability into Hubble such that it really is almost a brand new telescope. I feel so good about that when finally I gave Hubble a last little pat and a salute, I sort of said to myself inside the spacesuit, you're the man. Of course, it's a satellite. But, and good luck on the voyages. And I felt not sadness at that, but really incredible satisfaction that we'd achieved all of those challenges and that we were sending Hubble off on what is a brand new adventure.
That's well said. Well said. That's great.
I have a question. Is it actually possible to reach absolute zero in space?
No. Okay. It's not. And that's turns out, that's a really deep question. It's not a simple question, but it's one that involves physics that's totally outside of our own experience. It's the very smallest scales, and it really gets down to the question of what is space, time, and matter. And although we don't have a great understanding of that, the real answer is that you can't ever really achieve a steady state of absolute zero.
Nothing comes from nothing.
Yep.
But it's still darn cold out there.
Yep.
Hi, my first question is for John. John, you never spoke about what that second tool was to get the bolt off, to get the camera out. Could have been WD-40 by any chance?
Well, I was thinking about that while we were out there because those bolts are lubricated to prevent them from getting stuck like that. The number one rule that I always teach the other spacewalkers that I'm leading on these Hubble flights, I've been up there 3 times, and I learned from a master, Steve Smith, on what was the 3rd servicing mission, is number one rule, don't break the Hubble. And so when we put a wrench on a bolt, we actually have a little device that has springs in it that prevent us from over-torquing it. So if you go to too much force, suddenly that'll slip so that the wrench slips instead of breaking the Hubble. And so we had that wrench set in there, and we actually in this case Drew was cranking on it, and suddenly that thing slipped. Well, we can increase the torque a little bit in steps, and we did that all the way up to the end of what we could do. And it happens to be 45 foot-pounds or so. And so what we had to do in the end was, and we tried a couple of different sockets and wrenches, and finally we had to take that out of the loop. We just pulled that out and put the wrench straight on the bolt. That means, if you pull too hard, the bolt's going to snap off, and then that's the end. You can't get the instrument out. And so we had to go to that extreme. And fortunately, it broke loose, so to speak. It came loose just above where that torque limiter was operating in. So we just got lucky. Of course, then later on, I had a similar one that had been installed with the same tool. And when I went to do it, the same thing happened. But this time we knew at least what the procedures would be to get it unstuck. There's still that moment when you're about to, okay, is it going to break?
The line is first do no harm. Is that?
Yep, that's right. Don't break the hull.
And I have one more philosophical question. I think everyone here values space exploration and the value of that. We all understand that, or we wouldn't be here. But can you talk about, in an era of tight budgets, the value of manned space versus more robotic and unmanned space exploration?
Yeah, we had part of that debate up here earlier, didn't we? When Buzz was still here.
Yeah.
I don't think you ever got to address it really.
Let me give a couple of quick comments about it. I mean, I think it's a little bit of a false debate. I think the truth is that there is room and need for both. Robots can go right now places that humans can't, and humans can do things that robots can't at the moment, or at least much more efficiently. And here's the example I like to use. If my friend Steve Squires, who's the lead scientist for the Mars rovers, Spirit and Opportunity, that are still 5 years later, the Energizer bunnies on Mars, they keep going and going. I actually have asked him this question. Okay, if you were a geologist, which he is, and I am, on the surface of Mars, how long would it take you to do what the rover does in a day? And what the rover does in a day is maybe it drives 50 meters or something. It looks at a rock, it might dig into that rock a little bit, and it tries to figure out what kind of rock it is. That's basically what a geologist does. How long would it take a human to do that? It takes the rover a day. He said, I've timed it. I've taken my science team out in the field and I've timed it, 45 seconds. So you can imagine that there's a heck of a lot of efficiency that you get out of having humans there. In addition, human eyes and hands and ears can give us the observations that frankly we don't yet have the capability to get with robots. There's an incredible amount that robotic exploration does, and most of the missions we do at Goddard are robotic exploration. It's amazing. But I think there's absolutely room for humans in that loop as well.
Thank you very much. I just wanted to let you know we have time for, I think a couple of more questions, and you're one of them.
Hi, my name is Erica, and my little brother hopes to be an astrophysicist when he grows up. When you all were little, did you ever dream about doing what you're doing now?
Charles?
Well, I couldn't even pronounce astrophysicist when I was a kid. And I didn't, but I wanted to follow in the footsteps of my heroes, as I said earlier, which was the military, those that served in the military in World War II. And so I decided as a junior in high school, a sophomore in high school, that I wanted to go to the Naval Academy. And so I started pointing for that, and I made it there. And when I got to the Naval Academy, I fell in love with airplanes instead of ships, and so I became a pilot. And so it's just a progression of one sort of step after another, if you will, that leads us to your final careers. And so I just tell everybody to dream, whether you're going to be a physicist, an engineer, a scientist of some sort, or a medical doctor. All of those disciplines are needed in the space program, and if your desire is to be an astronaut or involved in space, you can be just about anything you want to be.
We have lawyers and business people too at NASA Center, so absolutely.
One more question.
Hello, my mother has called me Barney Oldfield, but I am looking at all the arguments for continuing space exploration, and we are getting to the end of the shuttle program, and of course budget is one of the big mantras. What do we see in the international community in support, either with technology or continuing support with the intellectual science fields?
And money as well.
Let me start and then let Lori join in. My belief is that science is the international language of peace, quite frankly. I think when we join on scientific endeavors, when we join on endeavors of great exploration, that is a unifying theme amongst peoples on planet Earth, and it's been shown time and time again. Budgets are tight, but I really believe that exploration is this grand adventure that is such an integral part of us being human that we have to do it. Great nations are nations of great explorers. There's no question, you look at the armada of spacecraft that are around the moon. We've had Chinese spacecraft exploring the moon, and Indian spacecraft, United States spacecraft, and on each of these spacecraft, there's international participation, cooperation. So if there's no question in my mind that if we don't explore, and if we don't lead exploration in this great country, somebody else will. And I like it that we're the leaders.
Almost every mission we do at NASA is international these days. I mean, you can harken back to the Apollo-Soyuz, back when the US and Russians weren't getting along very well. We were exploring together in space, and I think, again, we can be trailblazers for nations, building bridges through space exploration with science, with human spaceflight, and we're doing that today. Almost every mission we fly is international, and that's something we're very proud of at NASA.
Amen.
I love that. One name was mentioned here earlier today, and it turns out that late in life, Walter Cronkite and I became very good friends and saw one another regularly. One of the things I remember most was a conversation I had with him in a restaurant in New York where he was talking about you. He was talking about space, and he always called it the biggest story that he ever covered, the most important story of these 2 centuries. He also put it in a way that I hadn't heard before. He said, all the news I was doing, there was Watergate, there was Vietnam, we were downcast. We as a nation, and maybe the world, was downcast. And he says, I'm not sure there's a word that I'm going to use, he said, but space travel, the space programs are upcast. He said, you had us looking up, beyond ourselves, our reach exceeding our grasp. And that's what we thank all of you for. And thank you for being here. Good night.